Good morning, good evening, good afternoon. I mean, these are virtual sessions, so it means that you can be at Asian time zone or maybe in Europe time zone, maybe US time zone. So happy to have all of you here. Today we're going to start with the Quarkus master course, the basic stuff, and then on Wednesday we are going to cover the cloud native stuff. So let's start, but first of all, let me share with you the master course slides and the workshop or the homework, everything that we are doing here in this presentation can be reproduced by you at home or at work without much problem. Here in the chat is on your, I think that it's in your left, right? You can ask questions there. And I think that today Sebi, my workmate, is here, really cool guy. So if you have any question, probably he will be able to answer it. And if not, because maybe he is in other duties, then I will answer you online. So I've sent the chat. I said in the chat the Quarkus tutorial. I mean that this is where all the exercises are, and also here I'm just putting. I think that it's in this way. Now here you can see the slides that we are going to use today and on Wednesday. Okay, so let's start. Before we start with our welcoming demo, remember that today we are here June 22 with the Quarkus basics. On Wednesday there is the Quarkus cloud native. Then 6th of July we've got Kubernetes basics and Kubernetes elementary, this July 6 and July 8, where we are going to learn the basics of Kubernetes. July 13 we've got Kafka, and then July 15 we've got Istio. So if you want to learn the basics of Kubernetes, Kafka, you are into event sourcing architecture, or you want to start streaming or analyzing your streams online, then Kafka, and then there is Istio if you want to improve the things that you can do in a Kubernetes cluster, then Istio is for you. My name is Alex Soto, I work in Red Hat, and if you got any question, you can follow me on Twitter and you can ask me there, or you can even send me an email and I'll be happy to answer it. Just before we go to the oh man, yes, I always miss to change this. Then yeah, you're missing nothing. Just remember that these dates: Wednesday Quarkus Cloud Native, Kubernetes Basics in July, Kubernetes Elementary as well in the first week of July, and then the second week of July we've got Kafka and Istio. Yeah, I just put it here the slide so you can remember. You can see my Twitter handle and my email. So if you have any question, please feel free to put it there. And just the last thing is that remember that there is a Quarkus virtual hackathon with a best overall application for $10,000, best serverless, best Kubernetes native app, best IoT, best migrated app. So there is a full of things to be done with Quarkus and with this Quarkus virtual hackathon, and please feel free to join there in this link, which I could even paste it. It's here. I pasted here in the message. And thanks, Sebi, for changing to the slides. This is something that with this demo things I am always focused on, starting doing the demo things and code, and I don't remember to switch the screen. Okay, now you can see my screen, so that's fine. So let me show you the first demo so you can see what we can achieve. I've got here my get pods. Notice that I've got here my Kubernetes cluster. In fact, it's an OpenShift, but you know that OpenShift is Kubernetes. At the end, OpenShift is the implementation of Kubernetes in Red Hat. You see that I'm in the default namespace with no pods running. In fact, just, so we can see it in a better way, I can do this, and then I can do a watch get pods, so you can see that there is no pods running anytime. And yeah, you can see that if you want to know where this Kubernetes cluster is deployed, it's not in Minikube. It will work with Minikube without any problem, of course, but in this case, I'm in Frankfurt, okay? I'm in Amazon, in Frankfurt, and it's an OpenShift version. Okay, now, here I've deployed a Knative service. Okay, Knative is serverless for Kubernetes. We've got a master course about it, so you can subscribe to the course to know how to do these kind of things. So anyway, this is the URL. I'm going to paste it here in the message so you can access. So the thing that you need to do is just access this URL. I'm going to do it right now. What you can expect here is that some pods will come to life. And that's the great thing. Oh, I noticed that someone is already accessing because you see that here has changes from running. So I can run it as well. And notice that say reader. Okay. So basically what I'm doing here is just when I need a pod, I just started the pod automatically, serve the request, stayed there for 1 minute. And if in 1 minute I do not receive any other requests, then I'm going to scale out to 0. So I'm not consuming resources, which means that my billing is going to be lower than if I was having there a pod running without doing anything at all. Okay, you can see, I see that all of you are accessing. Thank you very much, because it helps in the demo. I'm going to, generate some more requests. So why it's important for this kind of architectures or solutions is that you need to have a really fast boot up time, right? Because the pod is scaled to 0, as you've seen, and then when I get it the first request, I need to boot up really quick. I cannot stay there like 3 seconds waiting to boot up, and then after 3 seconds I can serve the request. This is not how this should work. And of course, if you want to go to Java, this can have some problems, because with Java you've got a really big boot up times. When I say big, I mean 1 second, 1.5 seconds, 2 seconds, which is acceptable for a monolith application, but maybe not so acceptable for microservices or serverless applications. What is the great things about this is that it's done with Quarkus. And let me just show you with Quarkus how much time it takes to start this application. It's done in Java, in Quarkus, which we're going to see today. But if you check in the logs, and I need to put, C user container, notice that has started with 8 milliseconds. So I've got a Java application with enterprise libraries, JAX-RS, JPA, beam validation, all this stuff that starts with 8 milliseconds. It's pretty fast. But it's even more. I can go here. I got here my Prometheus, and notice that this is my pod. This is my namespace, and notice that here's the CPU usage is really slow, just 0.015. So it's pretty slow usage of CPU. And notice the memory. Probably you are used to have some kind of big memory usage with the Spring Boot, Wildfly, or any other Vertex, or any of these JVM based applications where you've got like 200, 250 megabytes of RAM, and in this case I'm just using 33. You can see here 34.92. It's really small footprint. So what is the big thing or the great things about Quarkus is like small memory usage, small CPU usage, which means that you need to pay less for running your services in a cloud environment. And let's go to the slides, because now we have seen the demo. And so, what is supersonic Java? Okay, this is Quarkus, okay? And Quarkus, it's on Quarkus.io, so you can go to Quarkus.io and you'll see all a lot of tutorials, guides, how to getting started, and so on. Then, what we're going to see today is just the Quarkus setup, the configuration, how to generate a CRUD application. Well, basically we're going to do a get and a post, and then you'll get the point. The Spring compatibility with Quarkus, and also how to deploy in Kubernetes. Probably we're going to change the order how we show it, but we're going to cover all these things, and then in the Wednesday session we are going to see more like reactive stuff, health checks, and so on, so more advanced. So let's go back and say, I like to say this, the reaper of my death are really exaggerated, because Java has been dead for a long time. It seems that there are always a new language which should be the Java, the one who will surprise Java and say, okay, this is the new top language used, and it seems that it could be true. But then when you get it, the indexes, the TOVX indexes, the RedMong or the HackerRank, you see that Java is still one of the top most used languages. In this case, it's the number one. In this case, maybe it seems like number two. Here in 2018, well, okay, it's number two. We had always Java on top. It's because we still have a lot of things to show in Java, a lot of things to do in Java, which is really great. We've seen a lot of libraries that are done in Java. For example, coming to my mind Kafka Streams. Kafka Streams is a library that is only usable in Java, for example. But also there is a lot of tools. We can think about IntelliJ, Eclipse. We can think about, for example, Jenkins, right? If you're using Jenkins, then it's Java. So Java is everywhere. And that's really cool, right? But what's happened when you put it Java inside a container? And if you have run our previous master course, we showed you that what's happened when you are using especially Java 8 inside a container. Basically is that you are constraining the resources. And what's happening with Java, especially in Java 8, is that he is not aware, Java is not aware, the application is not aware that you're running inside your inside a container. He thinks that it's running inside a bare metal machine, right? And then it tries to grab all the possible memory. So for example, if you're running inside a machine which has 8 gigabytes of RAM, then Java will try to get access to 2 gigabytes of RAM. But what's happened when you're inside a container scenario? Well, you will see now in a moment what's happened. And with Quarkus, the good thing is that you can make it run it 10 times smaller, 100 times faster, and that's serious. And this is happening because basically what we are just doing is taking your application classes and resources, apply some kind of process which changes the approach that we usually did in the past. Basically, a lot of things are done at compilation time instead of at running time. So for example, when we've got all these injection points, we are resolving the injection points at compilation time and not at running time, which saves a lot of time and a lot of boot up time. But if you want turbo speed, not just going through Java mode but starting in 500 milliseconds, we want to start with 8 milliseconds, 5 milliseconds, then we can use GraalVM. In terms of Quarkus, you can think about GraalVM as a compiler which takes a Java application and it compiles to a native binary. So you can have a Mac OS native binary, or you can have a Linux native binary or Windows native binary. So it's a binary file like for example in Go, which makes it run pretty fast and with a low memory footprint. So basically you can think like we've got our Quarkus application with a runner jar, and then we take this runner jar and we do a native compilation and we've got a native executable. So what's happened if you are into the JVM mode and especially Java 8 and you put it Java inside a container? That it's going to explode eventually if you have not configured it correctly. And the reason is that Java is going to try to use as much memory as possible, right? And when this Java process gets out of the boundaries of the container, the kernel will say, oh look, there is a process that it's out of the memory boundaries, so I'm going to kill the container. Okay, this is not happening if you are using a native compilation, of course. So it's really important for making Java and putting Java inside a container to create a native binary, which will simplify a lot all the operatives. And of course, as you've seen, Quarkus application uses just small memory, 38 megabytes of RAM, and a slow CPU. And this means that you can either save your money by buying machines that are not so powerful because you don't need all this power, or you can increase the deployment density. The deployment density is the number of processes that you can run in the same machine. Since you need less RAM and less CPU, it means that you can put inside every node more and more processes because they have lower requirements. Quarkus loves Kubernetes. It's thought having Kubernetes in mind. And that's all for the slides, because this I want to be a live code session so we can start doing things. Let's create our first project. I can move it to, for example, TMP2. Basically, it's a directory where I put all my stuff. And let's create a new project. In fact, I see that you are still accessing the service. That's great. Then I can stop it this, and I can create a project. Then now we're going to create a project with the Maven plugin, but I'll show you later how to create it in other ways. Let's do a Maven IO, and here basically it's just it's in a staff. I'm going to update the version to 1.5.2. You set the group ID, the project artifact. Okay, let's change it because hello app. You set the version, which 1.0, the resource. I want to create another. Let's call it hello. Okay, this is the class, the welcome class, and the path. This is when you do the slash thing, right? When you do localhost 8080 slash, where you want to get. I want to get the hello. Okay. Now I created the project. Notice that it's a pretty new version because 1.5.2, oops, what's happened, it was generated, not supplied in the existing POM, no. I'm using the new version, so I might have project group ID, yeah, project artifact, yeah, it's there, I don't know why it's complaining. Okay, and never mind, I think that we call it hello. Okay, why it's not running now? Unable to generate the project group ID, project artifact, project version parameters are not supported when applied to an existing POM. Okay, I know what is happening, sorry. Probably what's happening is that I have here a hello app project already created. So, okay, now I need to put here 1.5. I just want to go to the latest one. Okay. No, why not? It's interesting. Okay, let me try this. Oh, never mind. Let's create another TMP directory. Sometimes. Okay, now. Probably, it was using the hello app that was in the temp. Okay, now I've got hello app. I can just go there and I'm going to start my IDE. In this case, I'm using Visual Studio Code. Of course, I could use IntelliJ or any other, but I like Visual Studio Code. Is a really light editor. It works pretty well, and also one of the great things that it has is that it contains, or you can install, the Quarkus plugin. There is also Eclipse Quarkus plugin and IntelliJ Quarkus plugin, but the one from the Visual Studio Code is really great. Then I can go here and now see that it's working as expected with 1.5.2 version, and I've got here the jars. That nothing really new. And if we see the created things, you see that I've got here a Docker directory with a Docker JVM. This is the Docker file used when you want to package a Docker or the Quarkus application in JVM mode. And here I've got a Docker file native, which is used when you want to use the native compilation. And finally, I've got here my hello.resource, hello resource.java, which you can see that it's probably it sounds you very familiar because it's JAX-RS. Notice that there is nothing really tied to Quarkus. It's just JAX-RS endpoint with the path / hello resource, text plain, hello, blah, blah, blah. Let me see if there is any question. Is execution, hi, Ba, is execution time also faster? I understand startup times less CPU and memory. No, the execution time, it will depend on your logic. Depending on the how your logic is, sometimes it's better and sometimes not. Basically, more than the execution time, what you get is that or you get a bigger degradation, in the sense that since you don't have a garbage collector as we understand in Java, or the just-in-time compilation, then if your process is going to run during 1 week or something like that, then you might have, or you might notice, depending on the usage, some degradation. So if you are going to native compilation, it must be for processes or for services that they are restarted more or less, let's say, once every 3-4 days, something like that. Maybe it's restarting because you're scaling up and down pretty fast, like for example in the Knative, or maybe because you are updating the version pretty often. So if you got a service that you are updating, for example, once every week, then also you can go to native compilation. Of course, this is changing, and it will depend a lot on your business case. For example, if you've got a service which is totally stateless, for example, some service that generates some tokens, some GWT tokens, or it validates some kind of data, so it's totally stateless, probably you can make it run for 1 month. But if you've got something, our kind of services, which generates objects, a lot of objects, starts dealing with the database and so on, probably you might make or make it run in a native compilation for 1 week or something like that. Of course, Quarkus is not mandating you to use the native compilation. You can use Quarkus in JVM mode, and then you don't have these problems because it's in Java mode, right? It's like Spring Boot or Wi-Fi, just in a JVM process, as you have seen before. So in these cases, you're not going to get these fast up times. Well, it's still faster and less memory usage than, for example, Spring Boot or, for example, Vertex. There is some comparisons out there, but you're not going to have this turbo boost thing. Okay, then let me continue. Yeah, now let me compile this project, compile package minus. I'm going to skip the test for now so we can go pretty fast. Notice that it contains Maven wrapper inside with this auto-generated project. Okay, and now let me show you the target, which is pretty interesting. If I go to target, you see that I've got hello EPP runner, hello EPP jar, and lib. This is the default behavior. Of course, if you want, you can create a uber jar. You know that a uber jar is like Spring Boot, that you contains all the libraries and all the jars inside a jar file. So you've got a really big jar file with everything there inside. In this case, by default, we are generating a lib library and a hello app snapshot runner. This is the runner, this is what you want to run. But if you want to distribute, you need to use this jar and also distribute the lib library. And probably you might say, and why this and not a uber jar, which is more, comfortable in terms of developer? The reason is that when you are into container wall, what's really interesting is to have a small layers, right? So you can reuse them. So usually in an application, the libraries is something that you are not changing pretty often. But what you are changing is your business code. Your business code is here, and the jar files, the libraries are here. It means that when you are doing Docker builds, since you are not changing pretty often the libraries, it means that the lib layer is reused several times. So you are saving a lot of space, okay? And then the only thing that you are changing is this small jar file. So you are creating a really thin container layers. For this reason, by default, Quarkus generates your business code in one place and lives in another. But as I said, there is an option which is it's called quarkus.package.uberjar equal true, and then it creates a uberjar, so everything inside, everything packed inside. Then, for example, if we want to run this, we can do java-jar target hello app runner. Notice that now I'm just running in JVM mode. This is not a native compilation. It's as like a Spring Boot or Vertex or Wildfly application, which is running inside the JVM. And notice that it takes 800 milliseconds to boot up. It's just still pretty fast, right? And now I can do HTTP 88/hello, and of course I get it, hello. Then, if you want to see, for example, now a test, let's see, for example, a test and run it. By default, it creates a test as well, this scaffolding process, and basically the only thing that you need to do is annotate your test with Quarkus test, and then using rest assured. This is rest assured, which is a really cool testing framework for testing in a black box way a Quarkus application or any REST application, right? So notice I'm saying giving when I get /hello, then status code might be 200 and the body is hello, and this Quarkus test annotation just starts or boot up your application once for all the test suite and then run all the tests. Notice that I do here a run test. You see that here how the application is boot up, then it's stopped, and notice that the test is green, okay, because, you know, yeah, it's still hello, right? So it's really easy to write and run tests or Quarkus tests. Okay, then let's move things further, and let's see how we could compile for a native compilation, right? And for this reason, you can do two things. The first one is do a native compilation for the current machine where you are running the Quarkus application. For example, in this case, it will be a Mac OS, so it means that I need to have GraalVM installed on my Mac OS, or I can use a really cool flag in Quarkus, which is doing is just taking my jar file, copying the jar file inside a Docker container, and creating a native compilation for running inside a Docker container. So it's a Linux native compilation, right? This is the way you can have Mac OS, but still be able to create a native compilation for a Linux system, so you can create a Docker image with this native binary. Okay, then let me switch to JDK 11 for a moment, because I think, yeah, now, because that for version 1.5 you need JDK 11 or 8, and in my case I was working with the 14. With 14 there is no problem with the JVM mode. The problem is when you're trying to do the native compilation. Basically, this constraint is because of GraalVM, not because of Quarkus. But anyway, I move it to Java 11, and now I just need to do the next thing. Maven compile package minus this keep test minus p native. So I'm just saying I want to create a native compilation minus d quarkus.native.container build equal true. So what I'm saying here is that I want to create a native compilation, and this native compilation I want to occurs or happens inside a Docker container. Notice that now it's doing a Docker run, embedding or mounting as volume the jar file, and then this jar file is transformed to a native compilation. We're going to see it in more or less in 1 minute or so. It's the time that it takes. It takes a bit of time, it's true, but I mean that it works. Let me see if there is any question. No, there is no more questions. That's great. Okay. Now, some people ask me, yeah, it takes, for example, this is just a Hello Wallet, it takes 1 minute. What's happening if I have a real big application? The reason is that the time is not exponential. Instead, it's really, really linear, in the sense that maybe a hello world takes 1 minute, but maybe a full application with database access and so on, maybe it takes like 1 minute and a half, right? Also notice that in my case, it's taking a lot of time, because if you see here my Docker properties, which are somewhere here, let me show you. Resources, you see that I'm using 4 CPUs and 8 gigabytes of RAM with 1 gigabyte of RAM for swap. Then, of course, if you've got more memory and more CPUs, faster time, right? But you can more or less think like it takes around 1 minute and a half for any kind of application. Maybe 2 minutes if the application contains a lot of jar files or a lot of external libraries and so on. But yeah, that's all. Notice that it takes a lot of time, because now we are changing the approaches. We are changing from just-in-time compilation to a hit-of-time compilation, right? So we need to resolve all the reflection things that happens on any application. This is the reason why it takes so long. Okay, now it's finished. So now I've got a native compilation, and in fact, if I go to target, you can see it here that I've got this in red, which means that it's a binary. Now, what's happening if I do this? It fails. Why? Because remember that I've used a Docker container to do the native compilation. It means that the native binary, it's a binary compatible with the Docker container, with a Linux system, not with a macOS system. For this reason, it's failing. So what do we need to do now? Okay, create a Docker container with this binary. And to do a Docker container with this binary file, it's really easy, because the only thing that I need to do is just do a docker build -f source main docker, because remember that I've got these files there. The scaffold process created for me. I think that here is native, and I'm going to create a new one, which is called, well, okay, with this tag, which basically I'm saying that the image must be stored at quiet.io /lord of the jars / hello native dot. Okay, now let's run it. Done. I've created my Docker container. Now I can do docker run -ti -rm -p 8080/8080, and I can just run this hello native thing. Okay, now it's just a docker run that starts with 26 milliseconds. This is the native thing that I've done. And of course, if I go here and I do an HTTP 8080 hello, you can see that I've got it again, the hello. But notice that now I've been able to compile my Java application with enterprise libraries with JAX-RS into a native compilation with a really, really quick time. But it's not only about, Quarkus is not only about having super boot up time and slow memory footprint and compilation to native and so on. It's another great thing, which is called dev mode or live reloading. This is something that people from JavaScript already knows, which is like, okay, I've got my .class file or my Java file or my script file, my JavaScript file. I modify something, I save, and then I can see the result. This is something that you cannot do it in Java. Usually in Java, what you need to do is make a change, do a Maven clean package, Java -jar, check the change. If the change is okay, then it's fine. If not, Control C to stop the process, go to my IDE, change the .java, save, Maven clean package, Java -jar, and again and again and again. Okay? Now, with Quarkus, you can stop doing this, because you can do something like this. Maven wrapper, compile, Quarkus dev. So I'm just saying I want to start Quarkus in dev mode. And notice that what's happening now is that it's compiling, and now it's listening for the transfer port, right? It starts. In fact, if I go here and I do HTTP hello, you can see that it returns hello. But notice that it's not stopped. It's there. Now, I'm going to my IDE. I'm going here. And now I don't want to return hello. I want to return, for example, Aloha. So I'm just changing. I change it to Aloha. I save the file, right? And now notice what I'm going to do. I'm going to here. I do HTTP hello. And I'm getting Aloha. Notice, no redeployment manual. I've not done any manual redeployment. I've not do Control C, Maven clean package, Java -jar, nothing. I just started once, Quarkus dev mode, and then it works. What's happening if we want to change Aloha to Ola? I save it here, and there we go. I've got an Ola. Also, what's happening if I'm, I do something like this? Well, there is a compilation error, right? Okay, here is the compilation error. Of course, it detects and it says, oops, you've got an enclosed string literal in return Ola. So it detects the error and it prints you the error, the compilation error. So let me fix it this. Okay, more things. Notice that I'm not stopping anything, right? I'm just, coding and then checking the result without doing Control-C, maybe clean package, nothing. Now, suppose that I want to configure the return value. Then all the configuration of Quarkus application is an application.properties file. Here is where you configure everything. Okay, and now I can create my own configuration property. Greetings.message equal hello world. Now, notice that I've created my custom configuration properties, and notice that it's in yellow. Why? Because I've got the Quarkus Visual Studio Code plugin installed. And says, you've created here a property, but this property is not injected in any place in your code. So why you're putting here? Okay, what we need to do is fix the problem. We can exclude it if there is any reason, but to fix the problem, we go to the hello resource, and I'm going to use another spec, which is the microprofile config spec. I can just do config property, this one. Okay, notice that it comes from org eclipse microprofile config inject config property, so it's not something tied to Quarkus. And I'm going to do a name. Oops, I think it was greetings.message string message, and now I can just return here the message. This code automatically will inject here the value of application.properties. And notice that now it's not yellow anymore, and the reason that it's not yellow anymore, it's because, the property is there injected. So now I can just go here, I want to do a clear, and I can do an HTTP hello, and you see hello world. Notice no Control-C, Control whatever, no Maven clean package, nothing. I'm just changing my code and everything works as expected. Then, what's happened now if you said, okay, that's fine, but I want to be able to package and deploy automatically to Kubernetes this solution. And for this reason, we've got some kind of extensions. Notice that I'm just going to add extensions. Adding an extension is just adding jar files. So to add jar files, I can go here and just create I've got a Kubernetes extension which allows me to automatically generate Kubernetes resources from annotations, and then also I've got Jeep. And notice that Jeep is used to create build container images in a Dockerless way. You can, for example, change to Docker. So you are going to use Docker for creating your images, but I'm going to use Jeep because it's really cool technology which allows me to create Docker images inside Docker. Now I put it there, and notice that if I open the pom.xml, you see that at the very end, this is just two new dependencies here, Quarkus Kubernetes and Quarkus Container Jeep. Okay, now I want to create a Docker image or a container image. So I'm going to do the next thing. I've got here, that if you are using, I think that it's, if you are using the Quarkus plugin, you've got some snippets. In this case, I've got one which is called zip, which is add container image properties. And for example, I can set the group. The group is Lord of the Jars. The registry is quire.io, and I want that I want to expose in the Kubernetes extension this service. Okay. Now I've got image registry. Here I could put it the artifact ID, the version, and so on, but I leave it by the default. The default is that the name of the container image is going to be the artifact, and I mean that if the group is not overridden, then it's the username and so on. And if the registry is not set, for example, it's Docker Hub. Okay, now I've got all these things, and here you can see that I've got this repository in Quai, which contains nothing because it's just empty, because it's to store my hello app container image, but still not there. Then what I want to do now is do the next thing. I'm going to stop it here. What I want to do is create a Docker image, deploy this Docker image or push this Docker image to my registry, in this case is Quai.io, and deploy the Kubernetes application to my Kubernetes cluster. So the only thing that I need to do now is just do this. Memon wrapper compile package the skip test minus the quarkus.kubernetes.deploy equal true. So what's going to happen now is that I'm going to build my Docker, image. I'm going to create my Docker image using Jeep. You can see here that I'm using Jeep. I'm going to push this image to Quai.io, and then I'm going to deploy this application to the current Kubernetes cluster, which is this one where I run the Knative thing. Notice that now I'm generating a JVM container image, not a native image. If I added in this flags -p native, -p Quarkus native container build equal true, then it's the process exactly the same, but it takes more time because I'm just creating a native compilation image. Okay, now this is just creating the Docker image. Probably it's pushing something. Sometimes the push process takes a lot of time. Okay, not yet. Let me check. Sometimes it's like this. I'm just checking here. Okay, no worries. Let's do it again. This Quarkus.container image registry required, load the jars. Yeah, sometimes it takes. I mean that it's when it tries to authenticate with Quai.io, it gets some time. Notice that now it's working pretty much better. Maybe. Now, yeah, done. Okay, now notice if I'm going here. What you see is that there is a new container of Lord of the Jars Hello app a few seconds ago with version 1.0 snapshot. So this is my container, and if I go here and I do a kubectl get pod, you can see that the Hello app application is up and running 23 seconds ago, and I can do kubectl get services, so get service. And you can see here that the greeter has, wait, because no, it's Hello app here. It contains a cluster IP. You could change this to, for example, be a load balancer stuff if you would, and then this Hello app will be accessible from the O2 wall, not just the internal wall. Okay. Now, if you want to see that this is really what we have done, I can just do kubectl exec -t /bin/bash. So I'm accessing into the pod, and probably wait because maybe okay. Now I can do call localhost 8080/hello, and you can see here the hello wall. So you see that with just one command, I've been able to do all these things. Of course, I can do a cat target Kubernetes YAML, and you see here the Kubernetes file that has been generated for you. Notice that by default, adding the Kubernetes extension, I am generating all these service account, service, and this deployment, pointing out to the Docker image that I've created with some configuration, and the ingress there also prepared to access, right, to this application. So, easy thing. Now, what's happening if you say, that's fine, I really love this, but I'm coming from the Spring Boot wall. So I don't want to learn new annotations, and that's fine. The only thing that you need to do is add a new extension. Let's create a new extension, and in this case I want to use, for example, notice that I can use Spring Data Edge API or Cloud Config or the Cache API, but I'm going to use the dependency injection thing. And what else? And for example, I can use them also the web API. So basically it's the most used Spring things, right? Now I can go here, and I know that I don't want to use this. What I want to use is REST controller. I'm not a super expert of a Spring. Not now. Let's see. Let me see if the wait. Notice that I've created here all the Spring DI and Spring Web dependencies, and let's see now. REST controller. Notice that this REST controller is from a Spring framework package, so it's not something related to Quarkus, it's the Spring thing, right? Then here I can change this, right? I can, if you want to inject configuration values, you use the value, right, in a Spring, so I can just use the value. Notice that now I can remove this. Notice that this is the Spring framework annotation, and now I've got this, and you said, but it's not in this way in case of a Spring. What I'm used to use is get mapping, and basically I'm setting that the path is /hello, right? Notice that now I can remove everything, and now from the point of view of bytecodes, if you will, or not bytecode, but let's say code, it's just a Spring application. I'm just having here the Spring annotations. Then I can go here again, I can do Maven wrapper and start in dev mode, and I can do here a call to localhost 8080/hello, and I'm getting the hello wall. But in this case, as you've seen, I'm just using Spring framework annotations. So if you want to learn, if you already know enterprise Java like JAX-RS, Beam validation, and so on, you can use these annotations. If you said, I'm used to use Spring Boot, then you can use also Spring Boot application. But remember that you need to add the Spring extensions, right? Which at the end, you can see here, are these two POM files. Okay, let's move forward to another example, because we are running out of time, but I'm going to go really fast to do it, which is what's happened if my application is not that simple like that, but it's a database application. Okay, now with Quarkus, we are offering a Panache. Panache is a framework that implements the data access object pattern and the active record pattern, which allows you to access to the database. Okay, and you will see now, you can think like a simplification, if you will, of Hibernate JPA. Then now, instead of using the Maven, I'm going to use this web page, which is code.quarkus.io, and basically you go there, you set the group, the artifact, let's call it, for example, in this case, I don't know, DevNation. And the build tool, you can choose Maven or Gradle, but I'm pretty old, so I'm using Maven. The age makes you choose the things that you feel more comfortable. Then we need to add here our extensions. What do we want to do? We want to do several things. The first one is marshalling and marshalling JSON objects, right? From Java object to JSON object and so on. So I'm going to use JSONB. So I want to use JSONB as a marshalling technology. You could choose Jackson. Notice that here is Jackson, but I like JSONB. Then, for example, I'm going to use, we said that we need Panache, which is that framework to simplify, as you can see, read here, what is Panache is simplify your persistence code for Hibernate or REM via the active record or the repository pattern, right? So we're going to choose Panache, and then I'm going to use OpenAPI. OpenAPI is another spec from microprofile specification, which the good thing is that comes with Sugar UI. So for the purpose of this demo, I do not need to create any kind of user interface. open API there. And then finally, I need also to add the driver, the JDBC driver. This JDBC driver, in this case, I'm going to use MariaDB. There is support for Microsoft SQL, Maria, Postgre, CockroachDB, H2, DB2 in the next version that we're going to release in 2 weeks. That is also DB2, so yeah. Okay, now we've got everything there, and now I can do a generate, and it just downloaded the zip. Now I'm going to move this zip from downloads webnation.zip here, and then I'm going to unzip. Nothing really new. We have seen this before. I can do code period, and here I've got the project. Now I need to start a MariaDB, and in this case I'm going to use a Docker image of MariaDB. So I've got the database there up and running. So I've got my database started, my application here, and just in case, or yeah, so you can see all the things. I've got here SQL Pro, which is a, I don't know if it's open source, but it's free, to check the database's changes. I'm getting localhost, yes. The username, I don't remember, I think it's developer, yeah. Developer, database is MyDB. I can do a connect, and notice that now the database is empty, there is nothing. Now, let's move forward and let's start creating a new entity and, you know, all this kind of code. I'm going here to Java. This is exactly the same thing that we've seen before. And I'm going to create a developer.java class. This is a class, and now this class, I want to implement the active record pattern. The active record pattern is something that people from Ruby or Ruby on Rails are pretty familiar, which basically is that the entity itself is the one who is responsible of implementing the operations to insert into the database, to update, to delete, to find by key, but to find by query, and so on, right? Then, by default, if you are using Panache, you can use active record pattern, and it already implements all these methods. For example, I can do here extends the Panache entity. Okay, and this Panache entity already implements a auto-generated long ID. So I do not need to take care of the ID. Of course, this can be overridden and so on, but for sake of simplicity, this is how it works. If you say Panache entity here, okay, you see that, for example, there is a persist method, a persistent flush, delete is persistent, flush, and then here there is some method to find by ID and find by query, or, you know, streaming, find all, list, and so on. We're going to see now, but just you can see what now my developer can do. Now I'm going to do entity, an entity. This entity, notice that it's a JavaX persistence entity, so it's something that comes from the JPA spec. It's nothing related to Quarkus, and I can just create 2 columns. Column, string name, column. Again, notice that this is the JPA annotation, and here I'm creating 2 attributes. Notice that the attributes are public, and you would say, why are you putting this public, man? You are breaking the encapsulation thing. And that's not entirely true, because now it's true that these fields are public, but when I'm compiling this program, Quarkus is changing the scope to private and generating a getters and setters. I'm changing in all your code where you are referring directly the fields to use the getters and setters. So you can just leave it here as public, and then it will, you know, automatically change to private at compilation time. Now I've created this my entity. That's fine. And then let's move here. Let me change this to developer. I want a get method. This get method, I'm going to put the producers in the, you know, here, and it's not producing a text, it's producing a JSON object. And also I'm going to put consumes, because this I want that it consumes media type dot JSON. So now. Okay, now I know that my endpoint is going to consume and produce JSON files. This is a get, which returns the list of all developers. We can change this to developers, for example. Then, how I can return all the developers that are in my database? Well, it's really easy. I just need to do developer dot find all or list all. I think that there is also list all. Okay, list all. Easy. This developer is my entity and it contains an static method which allows me to do a list all the developers. And of course I need to change this to list of developer. Okay, now this method just goes to the database, finds all the developers and return back all developers. What's happening if I want to store a new developer? Okay, now I need to do a post public developer create. This receives the developer, and the only thing that I need to do is just do a developer.persist. That's all. This method persists this developer, and finally return developer. So I want to return the current developer. Now, since I'm just creating a new developer, I need to make this endpoint transactional. This is something that is different from Spring Boot. Spring Boot by default, the endpoints are already transactional. If you're using, for example, a Spring Data JPA, but if you are using, in case of Quarkus, you need the specify that this endpoint is transactional. Okay, so I'm just using the transactional spec. That's all. This is all the things that you need to for developing something. Now you need to configure the database, which is pretty easy. Again, since I'm using the plugin, the Quarkus Visual Studio plugin, there is one well, let's wait until it loads. Here it's Quarkus, configure Quarkus data source, which I want to configure a Quarkus data source for MariaDB of kind MariaDB, username developer, password developer, generation update, because I want to auto-generate all the schema, and that's all. The only thing that you need to change here is put here GDBC. The reason is that in the previous version of Quarkus, the URL was quarkus.datasource.url, but now in the new version, it has been changed to .gdbc.url. Both are supported, but one is going to get it out of, or deprecated out of supported, so I suggest you always use now quarkus.datasource.gdbc.url property because it's the new one. And I think that that's all, because we are running out of time, and I think that I've been able to done it correctly. Now I can do Maven compile Quarkus deb, which is going, if we are lucky enough. It's downloading everything again. And there we go. Now if I go to SQL Pro and I say a refresh, you can see that my DVD contains a table, which is developer, which contains the ID, the age, and the name. And remember that I've added before that the OpenAPI spec, and I said this adds the Swagger UI by default, so you do not need to implement any UI. So I can go to localhost 80 Swagger UI and see here my two endpoints, one with the get, another with the post. So I can push the post, I can put try it out, I'm going to remove this ID, and I'm going to put here my name Alex, and my age 39, I can do an execute. Notice that it's executed, and if I go to this database and I do a refresh, you see that Alex is here in the database, and of course I can even go to the get, do a try it out, execute, and you see here that it is Alex. Now, notice that I'm still hey replicant, now yes, there is a Quarkus extension for IntelliJ, for Eclipse. I think that for NetBeans also there is an extension, but I'm not super sure. And also this one for Visual Studio Code. So yes, it offers similar experience. And then let me finish this by showing you the last thing. Notice that I'm in dev mode. I'm not repackaging anything. I'm not stopping and starting. I'm not doing Maven clean package, nothing. But now what's happening if I want to add a new column here? I do column, public, string, favorite language. Okay, I've added a new attribute, right? And you will say, okay, now you are changing the database. I'm just adding a new field in the database. Then I can go here, of course, and I can go to Swagger UI. I can do a post developer, and notice that here I can try it out, and now I've got my favorite language here. Notice that I've not done any Maven clean package, Maven install, Java minus-jar, blah blah blah. Nothing. I'm just developing. Then I can change this to 7. I can favorite language, for example. I put here Scratch and name other, and I can execute it. And what's happened? Okay, the developer Ada has been added, and you will say, but you have added a new field in the database. How is this possible? Notice here, I'm going to refresh it, and here you see the column. Null with the previous fields, favorite language with a Scratch with the new fields. So what's happening is that the live reload is also being able to, change the database schema on the fly. So you can add new fields and then boom, they are updated. And notice that probably this is not something that you want to do it on production, I agree. But as a developer, when you want to, you're developing and you want to see your experiments, maybe what's happening if I annotate this with this annotation or this with another annotation, or this is a one-to-many, many-to-one, and I'm not pretty sure how they work. This is a really cool technique to see the final results really, really quickly. Then we are almost done, because I'm going to the slides. For the last time, just remember that if you are really interested in Quarkus and you say, this is really cool, on Wednesday we've got another session for the Cloud Native. There is also this book, Quarkus Cookbook, where you're going to there is a lot of recipes for the Quarkus. I'm the author or the co-author, so feel free to take it a look. And of course, remember, if you want to be involved with Quarkus, Quarkus.io, Zulip chat as well, and also Twitter. Then let me check here. See that there is a question. And hey, Constantinos, you said, is Oracle DB supported? No, it's not Oracle DB driver supported. The reason is that Oracle DB driver is not open sourced. It seems that they are going to do it maybe someday, but it's still not supported. This is the reason, because it's not open source. And notice that Oracle DB driver can be used in JVM mode. So if you go to JVM mode and you add the Oracle DB driver, then it works. But if you want to do a native compilation, and you will get it an error. Okay, the reason is that the drivers are not native certified. Okay, then what you need to add these drivers with an extension, because what we have done is change or add some kind of code to make MariaDB JDBC driver native compilation aware. The same for Postgres, the same for Microsoft SQL Server, and so on. But Oracle DB is not open source, so we cannot make these small changes to make them native compilation supported. But again, you can use Quarkus in JVM mode and Oracle DB without any problem, but you will not be able to compile it to native. This is an interesting question, because it's always the same. Quarkus in JVM mode, everything is supported. Quarkus in native mode, you need to add these extensions. It's the reason. I think that this magic that Quarkus does for public-private fields can be very surprising. Well, I've not seen any surprise yet. I mean, that I've been playing with Panache a lot. I've not seen anything. In fact, if you want, you can go to your code and you can generate your getters and setters. So for example, here I could create my own getter, for example, on get age, and now I'm put here, for example, sysout age. Okay, so I'm providing my own get. Of course, you could put here as private and create the methods. It's not a big deal. I mean that you can still do as you usually do, putting this private, and generate all the getters and setters. But yeah, you are only putting more and more stuff in your code. With this public approach, your entities looks really, really thin, right? But you can still put it there private or even public and create your own get, and then Quarkus will not generate the getter, but it will use this one. And you can see this because if I go here, here I can just do a get, here, get, try it out, execute. Now you see that here are again all the developers, I guess, yeah. But here notice that now instead of using the getter of the one provided by Quarkus, you're getting the get method that I provided printing the ages. Yes, as Sebi said, saying Sebi, you can still use the old school way. As I said, you can use this public thing and provide your own getters and so on, as you've seen, your customization, or you can say, okay, I do not feel very comfortable with all this public thing. I'm going to put it private and getters and setters. So that's perfectly fine, yeah. And thank you, Konstantinos, to you for coming to the session. And I think that's all. But please, if you got any question, remember Twitter. Let me put it again, just in case someone missed it. If you've got any question, just remember Twitter. You can follow me and you will get notices about all master courses and everything. You can also subscribe to the channel if you want to, get it updated with all the videos that we are doing. And of course, email is another option. And thank you very much for coming, and hope to see you on Wednesday. Bye bye.